To my YouTube channel Rizkat, and today we will see what it all are the delta H, how we can define delta H and value of Q in terms of heat capacity. Okay, so delta H or enthalpy, and how we can define this Q, which is heat, in terms of heat capacity, or Q is also the energy. Okay, so how we can define it in the terms of this heat capacity, which is C. Okay, so firstly we have to remember that the heat capacity C at the constant pressure is defined as Cp at constant pressure. Okay, and this is known as Cp. Okay, and Cv is at the constant volume, which is Cv. Okay, so these are the two, Cp and Cv. One is at the constant pressure and one is at the constant volume. Okay, so this constant pressure heat capacity can be defined as at the cost Cv is equal to del U by del T at constant volume. Cv is defined as del U by del T at constant volume. Okay, so this is the definition for Cv. Okay, and del U is also can also be written as Cv dt. Okay, so this is the equation for the del U, or the this is the internal energy. Okay, so or if the value of this Cv is the temperature of is is a function of temperature, so the delta U or the internal energy can also be written as integral T1 to T2 Cv dt. Okay, which is at the constant volume. Okay, so this is the equation for if it is at the constant volume, how we can define the internal energy in terms of the heat capacity. Okay, so for a reversible constant volume process in a closed system, the heat transferred is equal to the internal energy of the system. Okay, so this we have to remember that the reversible, if the process is reversible process, okay, and is the constant volume process. Okay, so if the process is reversible and a constant volume process and is a closed system, then the heat transferred is equal to internal energy change of the system. Okay, so Q is equal to N delta U. N is the number of moles and delta U is the change in internal energy. Okay, so Q is equal to N delta U. Okay, so like this we can define. Okay, so the constant pressure heat capacity will be defined as Cp is equal to del H upon del T at constant pressure. Okay, so the previous one was at the constant volume and this is at the constant pressure. Del H is equals to del H by del T at constant pressure is equals to Cp. Okay, so this is how the Cp is defined, or the delta H is equal to Cp dt. So this is how at the constant pressure the values will be defined. Okay, so dH is equal to Cp into Tt. In this also the system is closed system, which we have to remember that the system is a closed system. Okay, and the heat transferred is equal to the enthalpy change of the system. Enthalpy change of the system. Okay, so dH is equals to Cp dt. Okay, or delta H is equals to integral T1 to T2 Cp dt. This is when the Cp is function of temperature. Okay, so by integration we can determine the delta H. Okay, so we can determine easily by integration with delta H. So we remember that delta U was T1 to T2 Cv dt and delta H is equal to T1 to T2 Cp dt. So these are the two things which we have to remember. Delta U is equal to Cv dt and delta H is equal to Cp dt. Okay, so if suppose that Cv is given as a plus bt plus ct square, okay, and cp is given as at plus b by t. Okay, so these are the two things which are given and we have to determine that delta u and delta h value we have to determine, and these are the cv and cp. Okay, so delta u is equals to integral of cv dt. Okay, so a plus bt plus ct square into dt, which is delta u. So at plus bt square by 2 plus ct cube by 3. So this will be our delta u function. Okay, so suppose that temperature is from 0 to 2 degrees Celsius. Okay, so how we will put 0 and 2. So if 0 will put, we will get 0. If 2, so a 2a plus 4b by 2 plus 8c by 3. So this is how we will get delta u. Okay, and cp was at plus b by t. Okay, so cp was at plus b by t. Okay, and our delta h is integral of t1 to t2 cp dt. Okay, so integral of at plus b by t into t1 to t2, so at square by 2 plus b ln t. Okay, into t1 to t2. So this is how we will get the delta h value. Okay, so like this we can easily determine what is the delta h value for this. Okay, so how the value of q is defined? Q is defined is equal to n into delta h, which is n into integral of cp into dt. Okay, so if it is asked how the value of q is defined, q is equal to n into delta h, which is at the constant pressure. Okay, thank you.